Ladies and gentlemen, welcome back from our lunch break. I hope you used the past 2 hours for intensive networking. And talking about networking, two more information. We received some feedback from you that you were kind of confused how the networking probably works. Actually, this is about your Xing or LinkedIn profile. So this is really important that you put this information into your profile, complete the profile, because this is how the other participants can reach out to you on the Exchange Engage area. And also talking about the Engage area, you find plenty of information about our exhibiting companies, talking about more than 20 companies. And please make also use of the opportunity to arrange appointments with these companies. All of that is in our Engage area. Now, we are ready to start. Still a couple of keynotes and speeches and lectures ahead of us on this afternoon, and I'm really happy that Ralf and Jochen are joining me on this stage here. Good to see you, gentlemen. Talking about MBSE at Mercedes Benz, I'm gonna quickly introduce you. Jochen Epple is Head of System Specification and Modeling at Mercedes Benz Engineering IT. In his role, he introduces systems engineering methods and tools into the development processes. And we also welcome Dr. Ralf Frotscher. He is Head of Systems and Software Engineering at TWT in Stuttgart. TWT is engaged in the rollout of model-based systems engineering methods and tools at Mercedes-Benz in terms of coaching, support, training, conception, validation, and application. Now we are ready to start. Gentlemen, the stage is yours.
Thanks a lot, Mrs. Schöne, for the kind introduction. We are very pleased to be here.
Yeah, so we could start with an overview. We want to give you an overview on the rollout of Mercedes-Benz cars, an overview and a review where we started, actual status where we now, and a small outlook where we want to go. So step in. Let's have a look where we started in 2015. In 2015, we started with the project SEED, and SEED stands for Systems Engineering Enhancement at Daimler. The goal was to manage the complexity that results from the accelerating automotive change, and we were split in different disciplines like requirements management or requirements engineering, modeling, simulation, and systems engineering. And we started with the process analysis, with the tool assessment, with introduction about systems engineering and model-based systems engineering. We also developed methods for that. The motivation was the increasing complexity, the increasing safety criticality, and last but not least, the certification. So we started with a general information campaign about systems engineering, and we did the first GFSE or INCOSE certifications. They were very important for us to get a common understanding about systems engineering. It's very simple. You have to define the same wording and the same understatement so that you could exchange the ideas of systems engineering. So this slide we showed already some years ago. Maybe some of you were at the last symposium and saw that already. We also presented that to our board of management, and we tried to introduce system engineering and to explain how it should work. So to give an idea about function orientation and systems engineering. What you see on the top is the Mercedes development system, the product development process, and MDS is the name at Mercedes for that. The digital mock-up is a very basic functionality to develop cars. It defines the geometrical dependencies, and the digital prototype defines the physical dependencies. But this is not enough for a digital twin. We had to expand it for the functionality, which is almost defined in software and customer functions. And we add to the digital mockup and the digital prototype, the functional prototype to define the functions. And what we have to do is the same as in the other two parts. We want to define the digital validation, the interfaces, and we want to check the completeness of the functionality, including the consistency. And how could we do that? We define the customer functions on a vehicle level, and we do the breakdown to the system level. So we define the dependencies between the systems functions to build up a customer functions, and we call that effect chains. That's the idea to get a better understanding how the systems work together in a car. And the second step too, we make the breakdown from the system level down to the components and define the component functions, which build up, many of the component functions are put together to build up the systems function, and a lot of system functions are implementing the customer function. So this is the basic idea, and we have a common understanding about that. The next step should be to get in contact or to get combined with the product structure, and this is not such easy as we thought some years ago. We are still working on this. One important point is that we have defined examples, like we show it here on the charging system, to get a common understanding what we're talking about. So this is the first overview what we give, and now I want to step over to Ralf.
Yeah, let's have a closer look into where we started in 2015. As you can see on the slide, we have had an existing system and function management. You can observe this by the green frames here, and a traceable requirements management system. What was missing were the connections between them, like for instance the effect chains Jochen already mentioned. On the bottom of the slide, you can see the individual disciplines, the individual development disciplines that have been existing and are still existing, of course, using their own tools, their own methodology, with a relatively loose interconnection, especially when it comes to the upper levels of the V. So we discovered that we have the need for more traceability, also in order to manage the increasing complexity in the automotive development. So this led to the establishment of a unified MBSE platform. Now, where have we been last year, approximately? We have had some success. For instance, we did the rollout, or we are still continuing doing this, the rollout of DORS Next Generation as a requirements management tool for component and system specification. Using this, we achieved much more traceability than before. We also led the way to creating new system specifications that did not exist before, like for instance in ADAS. Second of all, which is a huge success, on the top right you can see this, we are at the stage of having 80 to 90 effect chains of customer functions ready, modeled in the platform. There is a total of 200 effect chains approximately, so there's some way to go, but we are we are on a good way, I think, to actually model the whole vehicle horizontally. And last but not least, of course, the supplier integration using the RECIF standard for the exchange of requirements documents. In 2020, we have a better integrated methods and tool platform. You can see it here again by the green frame, indicated by the green frame, that we have the effect chains ready, connecting the system and function management and the requirements management. So we get much more traceability by this. For instance, if you have an external regulation by law, for instance, we are able to localize the function that should take care of this regulation, also break it down to the technical requirements and get a link to the testing in order to identify which test covers which external regulation, not only mentioning the internal requirements, of course, from the development. We are not done yet, I would say. In 2021, we have multiple challenges still in the automotive development. You can see them here. Those are global challenges, so that's not Mercedes Benz specific. It's just for everybody. The vehicles become more and more software oriented. There are new vehicle architectures, like for electrical vehicles, that are partially totally new or partially integrated in existing architectures. Of course, the challenge of autonomous driving is a huge one, and the vehicles also become more and more connected to, for instance, other vehicles, to pedestrians, to infrastructure. So many of global challenges that even more require a complex change of the automotive industry.
Yeah, thank you, Ralf. Now we go from the global challenges to the Mercedes Benz challenges. These are the continuous delivery of software, intelligent and autonomous driving, certification, as we heard today in some presentations, and the partner integration via internet services. Additionally, maybe as you know, Mercedes is developing its own Mercedes-Benz operating system, and we implement a new car line with our electric cars EQ series. And hopefully you saw the great presentation of the EQS, Mercedes EQS, with his wonderful 56 inches wide hyperscreen. These are some of the challenges we have. And from an IT perspective, we have to implement all these necessary IT tools and IT functionality in the big picture for the V model from the left side of specification, including the testing and the approvals. So the automotive change is challenging on many levels, and MBSE is one or a key component to handle it. So what we are doing, how it could work, and we say we want to define effect chains for the model complex structural and functional connections. Application areas are the customer functions. We have to define the customer functions. We have to make a clear and clean breakout of systems and functions. Very important are the responsibilities. Where are the interfaces of the responsibilities for each department or for each developer? And we have to formalize the interfaces between systems and the functions, including the components. And all of this is implication of certification relevant software updates. So that means this is a base functionality to do the certification. So how we do it, we prepared for a logical level the MBSE platform based on IBM Jazz, and we are defining these models and the effect chains with Rhapsody, which is a part of IBM Jazz, including and with a very close linking to the DNG module for the specifications. So these models and these complex models require a simple UI. What is our problem? Standard modeling tools are designed for MBSE experts, like CAD systems for CAD experts. 90% of the model content consumers are non-modeling experts. Yes, they are experts in their specific part, but mostly not modeling experts. And simple navigation through systems engineering models are required so that we have a quick and easy dependency checking. That's very similar to the CAD world and the CAD 3D model. You know, everybody of you knows it. We have 3D models, maybe in JT, and we have a lot of JT viewer where we could use the view the model and take a look how it works. That's very easy, and most of them are not CAD experts. So similar to this, we need a very simple viewer and viewer function to view the functional dependencies on such models. And for that, we do together with TWT a first POC. It was implemented by our colleagues. And for more details, I will switch over to Ralf again.
Yeah, thank you. So as Jochen said, we created this tool. It actually works on actual model content. So you model your systems, your functions, the interdependencies, the interfaces in a modeling tool of your choice. And then we have here a web viewer. So it's a web tool accessing the model contents using, for instance, JSON as a format to convert it to a visual representation that is not only hopefully appealing but also easy to navigate for non-modeling experts. As you know, modeling is a quite complex task. There are many things to understand. Also, the tools are designed for experts, and here we try to hide all the information that is not necessary for the specific use case, and for the specific user to not disturb him with information that he doesn't need. So what you can see in this tool is basically navigate through the system and function structure of Mercedes Benz, and the second what you can do is to watch the effect chains like on this slide that you see now. You have the functions that have a name. You also can see how they are interconnected, and you see which information travels over the interfaces. It might be information, might be also mechanical connection, or maybe something else. Just an exchange between those functions. We would now like to go to the to give you or give us and you a vision of what we want to do until 2025. Things you can do with modeling, with model-based systems engineering, is formalization, for instance. So we want to consequently model requirements. We want to create meta models in order to ensure conformity between the across the requirements. We also want to formalize the requirements itself, to have a textual and a model representation, to be able to use automatic model checking in order to ensure the correctness of the requirements formally. What else can you do? Here is an example. The quality assurance of behavioral requirements. TWT had a research project called SafeSpec together with the Humboldt University in Berlin. And there we formalized the system behavior. We also formalized the verification conditions, and we tried to, this way, ensure the quality of behavioral requirements. If you want to see more of our research projects, please go to our website, or also on the end of the talk you will see a link to a showroom that might lead you the way. So in 2025, our goal is to really put into practice the benefits of MBSE. As you can see here again by the green frames, we try to cover everything in order to enhance the traceability. We also want to get the connection to the individual development domains ready. Also, the digital data package will take a part in this, probably. This way we get tool compatibility, we will focus on exchange standards, and then, hopefully in the end, really put into practice the benefits of model-based systems engineering. And now Jochen will tell you a little bit about the vision of Mercedes Benz.
Yeah, let's try to summarize. In the future, we are expecting even larger challenges due to the continuous automotive change. We need a transparency of the complex dependency for all the departments, and we have a clear vision. The vision is to implement the MBSE horizontally and vertically, and a functional prototype. They are the two key factors to solve the challenges that arise from the automotive change. With that, we get a transparency to involve all the departments, the developers, and we defined a logical level to combine all these information, a common view for the developers, and this is the base for digital validation, like we saw on the right side in the V model. We make the validation and approvals on each level, so starting on the software level, going to the component system level, and to combine it on the vehicle level. This is the basic for support the certification process. So the solution is not only handle the complexity, but also to develop new premium vehicles in the future, including all the innovative functions of Mercedes-Benz stands for. Thank you.
Ralf, Jochen, thank you very much. I received a couple of questions from the audience. There was one coming in at the middle of your presentation. I think you answered on that later on, but I'm going to ask it again so we can put in focus on it. So can you give an example for an affect chain?
Yeah, we do it. As Ralf shows us, effect chain means where it starts, where are the dependencies between two systems, like the charging system. Someone has to activate the charging, and this should be resolved or solved by the system who is responsible for the charging. So this was one on the slides. Maybe you could take a look at the slides.
Yeah, I was like, I think you've answered to that. I was thinking the same. So next question came from Alexander. How have you set up KPIs for monitoring of effective change and their repercussions?
Yeah, we already do some KPIs, but to speak very open, the main problem is to find the common KPIs. Yeah, so we had some KPIs. So just to count how many systems we have, how many specification we have, how many approvals we have, and this is very simple in such a product development system like MDS. This is already established, but to go on with this, it's not so easy because you need a common view on this, and we're still working on this. It's really a hard job. We know that.
Wonderful. The last question came from Thomas. Is SysML 2.0 already a part of your Vision 2025?
Yeah. I think so. Yeah.
Yes,
of course. We want to continue the development. We also want to improve every day, basically, and of course, using modern standards is part of it.
Ralf, Jochen, thank you very much for being with us today and for answering all these questions. Thanks a lot.
Thanks a lot.